Hello and welcome. We are in Unit 4 on polynomials, and this is the section for reverse FOIL. It's a visual type of factoring. The section title is 4.5. The pizzazz pages that go along with this visual factoring are 91 and 92 in your Algebra Pizzazz book. The definition of factoring that we've been using throughout this unit is the process of breaking a polynomial expression into its component parts. And again, this is the opposite operation to simplifying. So the opposite of simplification is factoring. So, and again, when we talk about factoring, we are using parentheses. So we can factor a GCF, we can factor a polynomial into two parentheses. We've talked about special factoring where we might have a difference of squares in a polynomial. So now we're on the point where we are talking about reverse FOIL. Now, when we talk about reverse FOIL, this is the general method for factoring. And it works with trinomials best, and it's where the leading coefficient does not necessarily have to equal 1. So reverse FOIL can be used for any trinomial. The leading coefficient we've talked about with third term factoring must be 1. But here with reverse FOIL, we can have other numbers besides 1. So an example of a polynomial with its leading coefficient, maybe not 1, in this case is 3x squared minus 5x plus 2. And here I've circled that leading coefficient of 3. So we can use this visual method. And let's go ahead and talk about the steps for the method. So the method for visual factoring, which in this case we're talking about as the method for reverse FOIL. Okay, and let's go ahead step by step. So step 1 in this method is, as always, to arrange the terms in descending exponential order. So we do this in alphabetical and descending order. So many of the situations that we've been discussing, and so far I believe all of the situations, we have not had to rearrange this. But it is important to know that we need this to be the case. The next thing for us to recognize is step 2, when we want to multiply the first and third coefficients. Then we're going to make a factor tree, so listing all the factors. So the difference here between third term factoring and reverse FOIL is that we're now incorporating that first coefficient along with the third coefficient. So when we multiply those together, we list those factors. And here, again, it's the concept of creating that factor tree on that list. We're going to circle the factor pair that adds to the second coefficient, so that middle term coefficient. And we're going to replace the second term with the pair, as we've done in our previous factoring methods. Okay, step 4 asks us to draw a visual FOIL box. So we're used to a 2x2 box. We're going to place the terms inside this box. And be sure to include your variables when you're creating the terms inside the box. We have in step 3, when we replaced the second term with the pair, we now created, rather than a trinomial, we expanded that out to be a 4-term polynomial. So with those 4 terms, that's what we're going to place inside that box. I'll show you this all momentarily in our first example. Step 5 is to factor the GCF, which is our greatest common factor, from each row and each column. 6 is to check. We have this FOIL factor box that looks as if it were a multiplication table, and we would check that as though we would a multiplication table fact check. And we're going to put our binomials. We have 2 of them that we're creating, and we'll discuss that. So our first example, to kind of show you what this looks like in an active setting, our first example is going to be 5x squared plus 21x plus 4 as our polynomial. Now again, this is a trinomial. There are 3 terms. And when we take a look at this, we're going to go ahead and multiply the first and the third terms together and make a factored tree. And 1 and 20, I can stop there because I know that 1 plus 20 is going to add to the second term of 21. So now I'm going to go ahead and replace the 21x with the factor pair of 1x and 20x and finish off my polynomial. So now I have my 4 terms, and I'm placing those 4 terms into this visual FOIL box. So again, I take these terms right here, these ones, and I place them into their sets here. The first term must always happen to land in this first section, so the upper left. And the last term must always land in the lower right. In regards to the 1x and the 20x being in these positions, as long as they're on the diagonal, it doesn't matter which position they turn into. I usually just write my 4 terms across this way so that I get them organized. Now what we're going to do is go into step 5, which is kind of the newer step for this whole method of visual factoring. Step 5 asks us to factor the GCF from each row and each column. So I'm going to take a look first at the column. So my first column I'm going to highlight in blue. Oops. And that went very quickly. So let me back up, please. Okay, see if I can slow this down slightly. So my first column is 5x squared and 20x. And in this case, I have the concept where my greatest common factor in this first column is 5x, because 5x can be pulled out of both 5x squared and it can be pulled out of 20x. The next section I'm working on is my next column of 1x and 4. And in this case, I have the concept where there's only a 1, a positive 1, that can be pulled out of 1x and 4. That's the only thing that they have in common, so it's my greatest common factor. So far I've pulled my GCF out of each of my columns. So now I'm going to take a look at the first row and I'm going to put that in red. So I'm going to take the 5x squared and the 1x and box those together and recognize that I can take, for my greatest common factor, an x out of 5x squared and an x out of 1x. That's the only thing that they have in common. Now, I look at the bottom row and it has 20x and 4. The greatest common factor amongst those is a positive 4. So at this stage now, my visual FOIL box has now been factored, and I'm going to take out my my check now. So to check this, I am going to use this as though it were a multiplication table. And in this case, a multiplication table, if I'm multiplying the term x times 5x, I'm checking to see that I get the term that they meet in this box, which is 5x squared. And in fact, that is the case. So I put a check mark, in this case a yellow check mark, just to indicate the difference. When I multiply x times a positive 1, I'm looking to see, do I get 1x? And in fact, I do, and so there's that yellow check mark. The next piece that I'm working with is 4 and 5x. And in doing that, I'm asking myself, do I get a 20x? And I do, so I'm going to place another yellow check mark here. Similarly, for the last box, I'm going to multiply the 4 and the 1. Both of them are positive, and I do in fact get a positive 4 when I do this. So I allow myself to place yet another check in the box. Since all of the boxes checked out, I can now put these into my binomials. So in doing that, I'm going to place the GCFs, the greatest common factors, for my columns into a binomial. So 5x and this positive 1. So I'm going to write out 5x plus 1. And my next GCF that I took out from my rows were x and positive 4. So that's going to allow me to write x plus 4 as my second binomial. In doing this, I've already completed my check in that visual FOIL box. Those are the yellow checks that you notice. So I am completed in this concept that 5x plus 1 times the binomial x plus 4, I get the polynomial, the original polynomial, of 5x squared plus 21x plus 4. Now we've done our first example. Let's go ahead and do a few more examples together. And we're going to continue this process. So again, the first page or piece that we're working on is identifying the reverse FOIL, and we're really looking to see what that leading coefficient, if it's perhaps greater than 1. So please title this next section 4.5 reverse FOIL, and our example number 2 is going to be as follows. Of 3x squared plus, or rather minus, 5x plus 2. So we've got this polynomial, and it in fact has 3 terms, this trinomial. And here again I have my first term coefficient is a 3, and my third term coefficient is 2. I go ahead and multiply those together to get a positive 6 and create a factored tree. So 1 times 6 and 2 times 3. Now I look and say, hey, I'm trying to find the terms that add to my second term coefficient with negative 5. And 2 positives when I multiply give me a positive, and 2 negatives when I multiply give me a positive. So I'm going to make both of these negative. And in fact, negative 2 plus a negative 3 is going to give me, when I add, that negative 5x. So I'm going to replace the second term, so 3x squared minus 2x minus 3x, and in that blue is that second term replacement. Now I'm going to place these 4 terms into my visual FOIL box. And in doing so, I have 3x squared minus 2x minus 3x and a positive 2 that I'm placing in this visual FOIL box. Now I'm going to do some work in terms of the greatest common factor. So my first column has a greatest common factor of 3x. Now I'm going to work here. It's possible that I'm going to have to take a negative out at some point, but the negative never comes out of my first term. So I'm going to recognize and leave this as a 3x, and just keep in the back of my mind I've got to work with a negative at some point, so I'm going to look for that. The next column that I'm factoring between negative 2x and x is a 2. Rather, I think I said that incorrectly. Let me retry that. So the first column is negative 2x and 2. So again, I'm pulling a positive 2 out there, and I'll make sure that I'm taking a look at those negatives at the end. Now, my first row has this 3x squared and negative 2x. They both have an x in common, and the bottom row has a positive 1 in common. Now, when I go ahead to check this, I know I have to have a negative in here somewhere, and I don't currently have any negatives. So we're going to work on fixing that. So when I go through this check, I'm going to see which sections cancel and which sections don't cancel. So x times 3x in fact gives me that 3x squared. So I'm going to place that yellow check just to confirm it. And when I go through that same process with all the other terms, so x times 2, I find I don't quite get negative 2x, so I've got to have a negative somewhere that's working out for me. And then the 1 times 3x, again, doesn't quite get me to that negative 3x that I'm looking for. And 1 times 2 does in fact give me to that positive 2. Now, since the diagonal terms here are the ones that did not check out, I'm going to place a negative in both of those sections. So I'm going to put a negative 2 and a negative 1. Because the negative pieces are the things that are telling me, hey, I'm struggling here to make this work and check out. So let's place a negative in both of those, and in fact, I end up with this checking out perfectly. Again, I can always make sure that that happens for this as well, because that negative 1 times negative 2 gives me the positive 2. So that's an important piece to check, and I'm going to write my binomials of 3x minus 2 and x minus 1. Again, you can always add the opposite to make this 3x plus negative 2 and x plus negative 1 if you prefer that method. They do mean the same thing. So let's take a look at example number 3. So the polynomial is 2x squared plus 6x minus 20. And in this case, I notice right off the bat that I have a GCF of 2. So I'm going to factor that out. Granted, I can use this reverse FOIL method, but I don't have to. It makes it much simpler if I don't. So in this case, I'm going to take the greatest common factor of 2 out of each of those terms, leaving me with x squared plus 3x minus 10. Now here, I can use third term factoring or reverse FOIL. Either method will work. But I want to show you what this would look like. So again, I can still use this method, or I can choose to take a look at my third term factoring notes from 4.3 and look through those. Since we're working on this, let's take a look, and I have that invisible 1 in front of the x squared and a negative 10 for my third term. So I have negative 10 that I'm making a factor tree out of. And I find that 1 times 10, 2 times 5, and the smaller one needs to be negative in order to add to a positive 3. So in doing so, I'm going to replace that second term. Again, I'm going to keep my greatest common factor out front so that I can organize this, and I get x squared minus 2x plus 5x minus 10. Placing those into my visual FOIL box, I'm going to take the greatest common factor out of the first column, and I find it to be x. And greatest common factor out of the second column, and I find that to be negative 2. So it's likely that I'm going to have my binomial, if I did this all correctly, as x minus 2. And that sort of works if you'll highlight this concept over here, that we already circled negative 2 and positive 5. At this point with the third term method, we could simply put these into binomials of x minus 2 and x plus 5. So I'm going to show you the visual method so you can see what it looks like had that visual method work. And in fact, I do get those same binomials. And it checks out, which is great. So the only thing I want you to keep in mind when I do this process is I keep the greatest common factor out front of that 2. And this would be the same concept here had I used the third term factoring from 4.3. So again, it's the same result as I would get from that. So if you enjoy this visual method, I find it very helpful to check my work. It also indicates a lot of pieces that make sense in my brain. Let's go ahead for one more guided example and then shift back so you have one try on your own. So this next guided example, we're going to have you title on that 4.5 reverse FOIL. And example number 4 says 3x squared minus 10x plus 7. Going ahead and finding my factor tree by multiplying my first and third term, I get 21. And I want this to be multiply to a positive but add to a negative, so both are negative. And in fact, the negative 3 plus a negative 7 indicate that middle term of negative 10. So I'm going to expand those out and make 4 terms and place those 4 terms into my reverse FOIL, or my visual FOIL box. So 3x squared, negative 3x, negative 7x, plus 7. In doing so, let's take the greatest common factor out of the first column, and I find an x, a negative 1. This goes so quickly for me. I'm going to back this up so we can organize in one step at a time. So the first column has a greatest common factor of x, and we can agree on that because 3 and negative 7 do not have another common factor. So the coefficient has no other factor beyond 1. X squared and x, I can take that x out. Taking a look at the next column, again, I still have those coefficients, just the negatives are in different places, and so I can only take out a 1. And in this case, I know from previous experience that I can take a negative 1 out, because when I had 2 negatives on my diagonal of here, I wanted to take 2 negatives out. So I'm going to go ahead and try it out to start with and see if negative 1 works for me. Then let's go ahead and look at the row, and I can take a 3 as well as an x out. And then my next row, negative 7x and a positive 7, I can take a 7 out, but I want to take a negative 7 in order to make this be a positive when I multiply, and this a negative and that a negative. So let's go ahead and check that this works. And again, I'm multiplying like I would in a multiplication table. So to do the check, I find that in fact I do have them all work out, and those negatives really were in the right place. So I place my binomials into, or my greatest common factors into my binomials. And I circle them up to remind myself of which greatest common factors go together. At this point, I get 3x minus 7 and the binomial x minus 1 rather. So our last is a try on your own example. I get this started for you, so let's take a look. It's 8n squared minus 5n minus 3. And I framework out what you're going to need to be doing. So I already circled your first and third term that you're going to multiply. Those arrows are telling you, hey, we're multiplying this in order to get this factor tree. Once we find the factor tree that the factor pair in this factor tree that add to negative 5, we're going to place those terms into this wonderful box over here. Okay, so the visual FOIL box, we're going to then take the greatest common factor out of each term and organize that. Please try this on your own. We'll correct it in class. I appreciate the effort that you're putting on in adding all the details in each of your notes. It will make your life so much easier when you take a look at those tests and you can see what those details are indicating.